Okay, so in this presentation, I'm going to be going over what permaculture is, why it's relevant to our lives, and how to apply permaculture design to a piece of land. So what exactly is permaculture? Although there's many definitions and many ways to think about permaculture, a simple way to kind of think about it is that it's the design and maintenance of agriculturally productive ecosystems and human settlements, which have the diversity, stability, and resilience of natural ecosystems. And essentially, permaculture harmoniously integrates the landscape and its people so that you can provide food, shelter, energy, and all your other needs in a sustainable and ethical way. So why permaculture? What can permaculture give us that other systems of living or other systems of sustainable agriculture cannot give us? So to answer this question, it might be helpful to kind of take a step back and situate human history within the Earth's entire geological history. So the Earth has been around for roughly 4.5 billion years. So if we were to represent Earth's history on a 24-hour clock, it would look something like this. And essentially what I want to draw your attention to is that humans have only been around for 1 minute and 17 seconds. So humans are like right here. So essentially not very long at all, a very brief period of time. And despite the fact that we've only been around for such a short time, and that's around 300,000 years, but almost nothing compared to the Earth's history. We've managed to destroy around 50% of forests, 50% of grasslands, and 90% of wetlands, and that's globally. We've destroyed this much, and we continue to do so. And industrial agriculture is one of the main players that's actually quickening the eradication of these resources and degrading them. So what about the future? Now, obviously, because of rising CO2 and climate change, things are kind of just getting worse. And we're expected to we already have actually higher temperatures, more heat waves, less predictable rains. And then the rains that do come are often in the form of droughts and floods. So it's more of a destructive type of precipitation rather than something that's more easily used. And then high biodiversity loss. And all this is expected to increase if things keep going the way that they're going. And conventional industrial agriculture is making these issues worse. And at the same time, it's also depleting our soil and water resources, which are basically vital to even have agriculture at all, or any kind of, human living. So in short, industrial agriculture is helping to turn the world into a desert. So going back to our question, why permaculture? So as conventional agriculture is destroying the things that it depends on to continue, permaculture, on the other hand, tries to correct this imbalance. And permaculture is more comprehensive than just sustainable agriculture or organic agriculture because fundamentally it's a design science centered around ethics. So here are the 3 permaculture ethics. They're earth care, people care, and the third one, return of surplus, goes back into these 2 ethics. So essentially we want to care for the earth, care for people in a balanced way. And then the surplus that we produce agriculturally, or it could be other resources as well, like water and soil, we want to return that surplus back into the first 2 ethics of caring for the earth and caring for people. So next, there's going to be an example of how to put permaculture into action by designing a piece of land with permaculture principles. And this was basically my final design that I had to do for the permaculture course that I took. Okay, so what we have here is essentially a satellite image, and a few different parts of this image are highlighted. So the area circled in red, it's about roughly almost 9 acres, which is about 3.5 hectares approximately. So this is the area that I will be designing. And to the north, we have a lake, and here to the east, we have a main highway. So this is just to kind of situate us. And the next thing that I did was I made a contour map. So a contour map is really useful for a variety of reasons. First of all, obviously it can tell you the elevation and the type of terrain that you're working with. A second reason it's very important is because a contour map can tell you where your water is flowing on a piece of land. So water always flows at right angle to contour. So for example, if the water was here, it would flow at right angle to contour, which would be this way, this way, this way. Likewise, for coming from this direction, it would be coming from here and flowing to the center over there, and the same for up here. So just by having a contour map, we already kind of have a lot of information, and we know that our water flows are generally going to end up in this area. So then we can design for that. And maybe we could, have more water tolerant species here, maybe species that don't like to be in waterlogged conditions higher up, for example. So just some examples of how a contour map can be useful for our design. The next part of the design is a sector map. And the purpose of the sector map is basically to show us all the different types of energy that are relevant for our site and might be something that we want to consider. So, for example, it's really important to know the sun angles. There's different types of sun angles. There's like the altitude angle, which is how high the sun is in the sky in different parts of the year. And there's also the azimuth angle. And here's a schematic to kind of better illustrate that. So this is especially relevant if you're anywhere far from the equator, because if you're close to the equator, then the sun angles will not vary so much, but farther away from the equator, they vary a lot more. So this is somewhere maybe in the northern hemisphere, where in the winter, we can see this is the azimuth angle from here to here. So the sun will be rising in the east, setting in the west. And it's a much smaller angle that we have to work with during the day than during the summer. So in the summer, still rising in the east and setting in the west, but it's much further back. So we have sun for a lot longer. And obviously the sun is higher. And so that's something we want to be aware of in our design, so that, for example, we don't block the sun, so we place our crops appropriately, etc. So going back to the sector map, that's what this is showing. It's showing us the azimuth angles, and the altitude angle is mentioned over here. And other things we want to be aware of is prevailing wind direction. So here the winds are coming from the south, and then specifically from the southwest predominantly. And then there's also tornado season winds coming from this direction and this direction that we want to be aware of. And then just other things like, okay, there's a nice view here because there's a lake, there's road noise and pollution. Maybe we want to block that with some trees or something. Okay, and the next thing here is we want to start thinking about our water flows. So this is a water catchment area map that shows the water catchment for the entire property. So essentially, this is telling us how much water will our site have to handle. So if the ground was already saturated and then we had a catastrophic rain event, how much water would we have to handle safely so that we don't end up with, structural damage or other issues, safety issues. And so this is taken by kind of seeing the different points of elevation, figuring out the area, and then figuring out how much your piece of land will have to handle. So this is the water catchment area that I mapped out for the whole property. And then there's a smaller area here, and this is the catchment area of the primary swale for the property. So at this point, you might be wondering, well, what is a swale? A swale essentially is a ditch on contour. So the fact that it's on contour makes it different than a normal ditch. And the point of a swale is that you can soak the water that's flowing, because remember, water flows at right angle to contour, and this ditch is on contour. So the water will be flowing straight here, and you can progressively increase the water capacity, the water holding capacity of your soil, and increase, just in general, rehydrate your landscape using a swale. And a swale is a tree growing system. So this is something you would use to plant trees, especially to stabilize this area and to make use of all the water that will be increasing year after year after year. You'll have a lot of water in this area from all the water that you've caught over the years. So this is just showing the catchment area for this swale. How much water will the swale have to handle, and how will it discharge this water? So this shows this shows some of the water features of the site. So again, this is the primary swale right here. It's the same one that's shown here. And this swale will be discharging its water once it overflows into this swale, and then this swale will discharge it into this swale, and finally into this area here, which is a marshy area, which is where we saw already on the contour map most of the water will be draining. Another thing I'd like to point out is these miniature swales over here. I call them mini swales. And so these are basically the same concept as these bigger swales all over the property. But the purpose of these swales is to act as kind of raised planting beds. But these raised planting beds are on contour, and these are going to be for the main crops in our design. And so it works by the same principle here, where it's going to be reducing our irrigation needs, because as the water collects, as it runs off contour, over time, the soil will become more and more rehydrated, which will vastly reduce our irrigation needs. And the crops will be planted on contour as well, and they'll be using up all that water. So it's basically a big help for passive irrigation. And then this map also shows us the access and structures. So in permaculture, it's always important to first figure out the water situation and then worry about access, and then finally structures. So access is things like roads. We already have a highway here and an inlet here. So the only access I've added is some footpaths marked in yellow. And then the blue is water tanks. And finally, structures. The main structure is going to be a learning center marked in green over here. So next we have a zone map. So in permaculture, there's a concept of zones to kind of spatially and temporally orient things in a way that makes sense. Specifically, you want to have the things that you have to visit every day to be very close to you, and those are the inner zones, and things that you don't have to visit very often, maybe just a few times a year further away, so in the outer zones, and this will help increase the efficiency of your design. So in the closest zone, which is zone 0, it's inside the learning center. Then zone 1, it includes things like a small community garden. And then zone 2 includes something like a food forest. And I'll go into more detail about this in another map, but just to kind of orient where things are. Here's a woodlot. We won't have to visit this very often. And then here's a wilderness rehabilitation area. Also, we won't have to visit it very often. So these are kind of the outer zones. These are the outer zones, zone 3 and 4. And finally, this is zone 5. And zone 5 is something we kind of don't touch at all. And it's considered just wilderness. And there's a reason for that, which I'll explain later. So here's the final design, which kind of puts together all the various pieces I already went over. But in addition to that, it actually has all the species. So there's a lot going on here. So I'm mainly going to just cover the main aspects of the design and not go so much into the details. But just for reference, this area here shows all the species that are in the design, and it corresponds to different markings here. So for example, TSA is an American sycamore tree, for example, and all the other symbols here correspond to a species listed over here. Okay, so maybe I'll start first with talking about the area near the learning center. So this area, there's a learning center here with an attached greenhouse. The attached greenhouse serves multiple functions. So taking a step back, part of my idea for having this learning center, in addition to being a place where people can learn about permaculture, why things are designed the way they are, and how it can be relevant to their own lives, it's also meant to be an example of an energy efficient dwelling or architectural space. So one of the main things I have is passive heating and cooling, and the greenhouse is a central component of that. So in the summer, the greenhouse is a place where younger plants or plants needing more care can be. And at the same time, there's going to be deciduous vine plants growing on the face of the greenhouse. So this greenhouse is actually sloping, so sloping down from the roof to the ground. And there will be deciduous vines, which during the summer will have their leaves and will provide shade as well as food. It's actually a species of grape that can produce grapes in this climate. And then during the winter, the leaves on the deciduous vines will drop. And so it will let a lot of light and warmth in. So during the summer, it's shading and it's helping us to cool. And during the winter, it's helping us to warm the area, not only the greenhouse, but the learning center as well. And there will be solar panels as well for solar energy capture to showcase how we can provide energy in a more sustainable way. And the solar panels serve multiple functions aside from just being energy capture. So they're on the roof of the greenhouse, which means that during the winter, the heat of the greenhouse will keep the solar panels functional and melting off the snow and ice that might otherwise accumulate on the solar panels. And in the summer, the solar panels will also help shade this area, in addition to the deciduous vines that I mentioned, to help increase the cooling effect. And then there will also be things which aren't really shown here, like solar chimneys, which are things that can help draw out the hot air, as well as ventilation and moisture control. And then if we move to the community garden area, there's two main areas. There is this area and there's this area. So this area over here, it's arranged in 3 layers: the deer tolerant layer, the deer repellent layer, and the inner garden. And essentially, what this is, it's a way to kind of try to make our community garden more deer tolerant. So there are deer in the area, and there's no more large predators in most of the US. So I've assembled this in a way where the things that are most attractive to the deer are in the inner garden, so guarded both by the presence of humans and by the fact that it's surrounded by two outer layers of deer repellent species, which are things that could be spiky or smelly or things that the deer don't like, and then some deer tolerant species. And that means things the deer can eat, but it won't kill the plant. And then here we have the other part of the community garden, and it actually has three sisters. So three sisters is a type of Native American gardening that uses companion planting. So here's an example of three sisters. Essentially what it is, it's corn, pole beans, and squash. And the corn provides structure for the beans to climb around it. And the beans provide nitrogen to the squash and the corn. And the squash with the large leaves basically prevents weeds and also discourages small animals from coming because they don't like to step on the spiky leaves of the squash. So it's kind of a way to have a planting system where the diversity all works together in a functional and efficient way. And then to the right here, we have a main crop area. So these are main calorie crops, and they're planted with nitrogen fixing species. These are the Siberian pea shrubs, and then also interplanted with hazelnut, which hazelnut can be used as a staple crop. In the past, humans relied a lot more on nuts as a staple crop, and it's a perennial, so it's much more better for the soil and better for the stability of the area. And you won't have to put in as many resources because you don't have to replant every year since it's a perennial. And then there's also some yam here, also a perennial, and kernza, which is a new type of perennial grain that was being developed for many years and is finally now ready. Here is a food forest. So a food forest is essentially a forest which has many layers like a normal forest. So a normal forest can have a canopy layer, which is the top layer, a mid-story layer, a shrub layer, a ground layer, and vines. So essentially a forest maximizes the use of space that's available in the vertical. So the same concept is used here, where we want to have species filling every niche in the forest, but we want them to be mainly food producing species. And that's what we see here. So there's some nitrogen fixing trees and shrubs to help provide fertility, balanced with food species, and even the nitrogen fixers themselves are edible. So things are multifunctional here. And then here we have kind of a barrier that's made of edible plants, but they're also spiky to help prevent deer coming in from the woods because there's a woods in this area. And then over here, there's kind of a parking barrier because there's like a parking lot out here. So this is an edible hedge. It's made up of hazelnut and some nitrogen fixing species, as well as some roses, which are, I think the specific rose used is rugosa rose, which is edible and provides rose hips as well, and helps block some of the automotive pollution. And then here there's a woodlot. So this woodlot is mainly trees that will be used for coppicing, which coppice is when you cut the trees in a certain way to encourage this type of thinner growth, which you can use it for firewood, for crafting, for different uses. And you can cut the tree at different levels to make different types of coppice. Like you could also want maybe thicker branches for mulching or something. So there's a lot of things you can do with that are very useful. So again, this is the woodlot area here where we have trees for lumber as well as for coppice. Many of the species are also edible, so they provide multiple functions. And notice that just as in the food forest here, everything is planted on contour. So we're making use of these swales. These blue lines are the swales. So this massively reduces our need for irrigation because we're catching all the water that's running off right angle to contour, soaking it into the landscape, planting trees over this, area that's full of water, and essentially drought proofing our land and really improving the water management, and very passively. So after the initial shaping of the swales, you don't really need to do much input at all. And then there are also some windbreaks. So there's a windbreak here, also made up of edible species that are wind hardy, and a smaller windbreak over here, made up of wood-producing species that are wind hardy. And in this area, there's a wilderness rehabilitation area. I won't say too much about this area other than it's planted with many native species to encourage native pollinators and also to encourage small mammals and deer to come here instead of the areas we would rather they don't come, which is more the gardens and the main crop area and somewhat the food forest. But essentially, the point is to balance things. So you don't want to completely exclude the deer and small mammals. Instead, you want to manage their numbers and maybe encourage them to visit sites where you don't mind if they go and visit. And so that's why it's planted with many attractive species for different types of animals in the area. And finally, we have here an experimental chinampa. So this area, and I'll explain what that is in a minute, this area is naturally very marshy because of all the water that is flowing in. And so, as you might recall, I mentioned that it's going to be left alone as wilderness. And the reason for that is it's already serving a really important function, providing habitat for different species. And at the same time, it's acting as a really good way to drain all our water. So any excess water flows will ultimately, from these swales, will ultimately drain here. And so this is kind of a safety feature. So if we were to do anything with it, it would no longer be able to act as a safety feature. And so that's why a decision was made to leave it as wilderness, except for this area here, which is the Chinampa area. And a Chinampa is actually historically the most productive agricultural system ever documented. And just as a schematic example, here's some Chinampas. And basically, Chinampas are made by taking the very fertile soil in shallow water bodies, piling it up in these type of extensions out into the water body, and then planting into them. So you can plant crops, you can plant trees, you can plant all sorts of things, and you never have to irrigate, obviously, because there's already water all around. And it's very nutrient-rich water as well, and you can even raise fish in some situations. So going back to my situation, it's much smaller and it's experimental because it's in a temperate area. Usually Chinampas are made in tropical areas, but this is kind of to experiment. And it's split into different zones. So the first zone will have plants that are less tolerant of too much water logging conditions. The next zone will have plants that are more tolerant, like wild rice. And then finally, here are some water plants to take advantage of this very watery area. And these water tanks are acting kind of like a safety measure in case this area ever gets too full, because we wouldn't want it to overflow and then, ruin the crops or ruin other things. And so these water tanks are here as a safety measure to kind of, in case there's ever a need to pump the water with a solar pump and store it in these tanks. And then the idea is to use it for irrigation if it's ever necessary. And then this water tank is just providing water for the needs of the learning center with rainwater harvesting off of the roof. And this is just a small shed over here. And those are the main components of the design. I could go more in detail, but I think, that's the main thing I wanted to kind of talk about. And the idea is to have everything working together, in an efficient way, in a productive way, in a sustainable way, in a way that makes sense. So I think that's it. And then these are the main tools I use to create the different maps. So pretty much almost all the information and all of the tools that are needed to kind of make a permaculture design are already free and easily accessible online. And there's so much data online, like there's contour data, there's climate data, weather data. Some of these are US specific, but there might be analogs in other parts of the world, like soil survey data, plant hardiness data, and other things as well. This is a design software. It's not free, but it's actually very affordable compared to Adobe. If you've ever heard of Illustrator or Photoshop, Adobe owns those and it's really expensive. You have to pay a subscription. However, Affinity Designer you only pay once and it's a very small amount, like $30 or $50, depending on if you get it on sale. And it has very good design capability. That's actually what I use to create all of these maps. So these tools are here and they're clickable links in case you would like to, explore further. And then finally, here are the sources that I've used for some of the data.